Welcome back to another Explainer. Today, we're looking at a piece of technology that is fundamentally, and I mean fundamentally, changing the landscape of naval warfare right before our very eyes. We're breaking down the U.S. Navy's Corsair unmanned surface vessel. Now, if you saw this thing out on the water, you'd probably think it's just another standard small boat. But the engineering, the speed, and just the sheer destructive power packed into this autonomous drone is absolutely staggering. We're going to look at the exact hardware, the real-world deployment, and the devastating physics behind how it actually operates. Okay, let's dive into this, because this single number right here, it tells you absolutely everything you need to know about the Corsair's true purpose: 1,000. That represents the massive 1,000-pound warhead hidden perfectly inside what otherwise looks like a completely unassuming, simple surface vessel. It's literally the ultimate wolf in sheep's clothing, designed to deliver just an overwhelming amount of explosive force right to the doorstep of a target. Section 1. Meet the Corsair drone, the hardware inside. On the surface, the Corsair's design is deceptively basic, but to understand why this machine is so widely feared, we really need to peel back that simple exterior and look at the highly lethal engineering that makes it tick. We already touched on the simple exterior, which houses a highly modular payload bay, ultimately making room for that massive 1,000-pound warhead. But the real genius is how it actually gets to its target. It's powered by a hybrid generator combined with a completely silent electric motor. So the crucial point is, this machine can push past 35 knots on the open water without making a single sound. It is a completely invisible, rapid, and totally silent threat rushing toward its target. Seriously, by the time you hear it or see it, it's already way too late. Moving on to Section 2. The July 2026 deployment, a historic mission. When this cutting-edge technology was finally taken off the drawing board and put into the water on July 12, 2026, naval combat witnessed a massive technological shift. This was the exact date the Corsair platform was deployed in an active war zone for the very first time. Now, regardless of the geopolitics of the conflict itself, purely from an analytical and military history standpoint, this marks a profound milestone in how unmanned surface warfare is executed. We officially moved from theory to reality. Let's move to and see how this builds. Because recently declassified Centrum footage gives us a really clear look at the exact strategy used on that day. The military didn't just send one drone, they sent a pair. The footage shows a highly coordinated attack. Drone 1 flanks hard from the right side, while Drone 2 rushes straight up the center. The ultimate strategy here was just blunt force, literally ramming the drones directly into an Iranian dry dock. But as you might guess, the dry dock itself wasn't the ultimate prize here. The target they were actually after was highly specific, and the stakes were incredibly high. Sitting elevated inside that dry dock was an Iranian submarine. The entire goal was to use these autonomous drones to neutralize a major, high-value strategic naval asset while it was exposed, well before it could ever hit the open ocean. Which brings us to Section 3, Anatomy of the Impact, the GBU-31 configuration. Let's slow things down for a second. We know the drones hit their target, but to really understand the terrifying effectiveness of the Corsair, we need to take a micro-level look at the exact split second of impact. Now, what's really interesting about this slide is the precise sequence of events mapped out here that takes place in a fraction of a millisecond. Right up at the very front of the drone is the fuse, sitting immediately ahead of that massive 1,000-pound warhead. The exact second that front end hits the target, the fuse triggers a conduit rod. That rod instantly detonates the main payload. It's an incredibly simple but frankly deadly mechanical sequence designed to guarantee the warhead explodes at the exact point of contact. There's zero delay. Section 4. Physics of waterline strikes, the strategic why. We've seen the hardware, the action, and the mechanics, but why design a weapon like this in the first place? Why use a boat? Think about this critically for a second. Why not just send a stealth fighter jet? I mean, the military has plenty of them, they're incredibly advanced, and they can drop bombs with absolute pinpoint accuracy. So why risk a brand new sea drone to hit a submarine in a dry dock? Well, the answer lies entirely in the physics of the explosion. Notice the stark physical contrast here. With an aerial bombardment from a fighter jet, you're delivering a top-down impact, right? The blast energy pushes downward onto the top of the hull. But with a waterline strike from a surface drone, the physics completely change. The military specifically needed a devastating surface-level impact because the resulting blast from the water level doesn't just push down, it aggressively surges inward and upward. And this brilliantly illustrates exactly what happens when that energy is channeled inward and upward instead of top-down. According to the official breakdown of the strike, this specific blast wave ends up, quote, completely shredding the submarine and the dock's structural supports from every direction. A top-down bomb might damage the top of the sub, but a waterline strike, it fundamentally breaks the structural integrity of both the vessel and the massive dry dock simultaneously. It maximizes the destruction by basically using the environment to its own advantage. It's just a terrifyingly effective use of tactical physics, which leaves us with a major, provocative question for the future of global security. As warfare shifts away from traditional massive ships and planes and moves towards silent, 35-knot explosive drones, how will global defense systems actually adapt to the physics of the waterline strike? I mean, when the threat is this fast, this quiet, and this structurally destructive, the old ways of defending a harbor are officially obsolete. Thank you so much for joining me for this explainer. I really hope this structural breakdown gave you a crystal clear understanding of this rapidly evolving technology. Keep analyzing, keep learning, and I'll see you next time.